friends, welcome back to our YouTube channel. Today we are starting the problems on the chapter 10. Okay, in the last class we have also started this only. Now next question. Let us consider a hydraulic automobile lift is designed to the lift cars with a maximum mass of 3000 kg. Maximum mass of 3000 kg. The area of the cross section of the piston carrying the load is 425 centimeters square. And what is the maximum pressure would the smaller piston have to bear? Here we have first they have given that mass m is equal to how much? 3000 kg. Next, the area of the piston carrying the load means area they have given. A is equal to 425 centimeters square. Convert this answer into meters square. Total answer 425 into 10 raised to minus 4 meters square. Next, here we have to find the pressure. P is equal to question mark. Here we have to find the pressure. First, they have given the mass. According to that, they have given area. We have converted area centimeter square into meter square. And here we have to find or we have to know the value of the pressure. Now, according to this, we know that formula F is equal to mass into gravity. Now, we know the value of the mass, gravity. Put the value of mass, M is equal to 3000 and G is 9.8. Now calculation part, F is equal to, we are getting the answer here 2940. F is equal to 29400. The calculation part of this, we are getting this one into Newton. Now we got the value of the force. By using this, we have to calculate the pressure. P is equal to, we know that formula F by A. Pressure is equal to force by area. Put the value of the F and A. 29400 divided by area. A is equal to how much is there? 425 into 10 raised to minus 4. Now the calculation part of F by A, we are getting the answer as 6.917 into 10 raised to 5 Pascal. Total answer for the pressure P is equal to 6.917 into 10 raised to 5 Pascal. Therefore, according to the question, here we have to find the maximum pressure. The maximum pressure at the smaller piston have to bear how much? P is equal to 6.917 into 10 raised to 5 Pascal. Now next question. In a car, the compressed air exerts a force F1 on a small piston having a radius of 5 cm. This pressure is transmitted to a second piston of radius 15 cm. If the mass of the car to be lifted is 1350 kg, what is F1? What is F1? Next, what is the pressure necessary to accomplish this task? Given that G is equal to 9.81 meter per second square. In this condition, we have to calculate the value of the force F1. F1 is equal to question mark. Next, what they have given data here. On a small piston having a radius of 5 cm. Means let us consider R1 is equal to 5 cm. Next, in the same way, they have given second piston of the radius that is 50 cm. R2 is equal to 15 cm. Now here we have to calculate the value of the F1. Now, according to the Pascal law, according to the Pascal law, we know that F1 by F2 is equal to A1 by A2. Now we know that area is equal to pi r square. Now in the case of the A1, A2, we are considering A1 is equal to pi r1 square, A2 is equal to pi r2 square. Now here we have to find the value of the F1. Therefore the formula for the F1 is equal to A1 by A2 into F2. Now the F2 value we are considering F is equal to M into G. Now put all the values, we can get the value of the F1. Therefore F1 is equal to A1 is pi r1 square by pi r2 square into mg. We know the value of r1, r2 and g. Put the values. Here pi get cancel the terms of the pi. Next the remaining term r1 square, 5 square divided by r2 square, 15 square into mass. M is equal to, they have given 1350 kg into 9.8. Now the calculation part. Now answer for this we are getting here 1.5 into 10 raised to 3 Newton. Therefore the value of the F1 is equal to how much? Here we have to calculate the what is F1. The value of the F1 is equal to 1.5 into 10 raised to 3 Newton. Now next question. The Story barometer used mercury. The Pascal duplicated it using the French wine of the density 984 kg per meter cube. Determine the height of the wine column for the normal atmospheric pressure. Here we have to find the height of the wine column for the normal atmospheric pressure. Here in this case they have given that density. Rho 1 is equal to 13.6 kg per meter cube. And second density rho 2 is equal to 984 kg per meter cube. And they have given the value of H1 height is equal to 0.76 meter. And here we have to calculate the height of the wine column. H2 is equal to question mark. Now acceleration due to gravity G is equal to, we are considering 9.8 meter per second square. Now according to this we can tell that the pressure in the mercury column, is equal to pressure in wine column. Pressure in the wine column. Now by using this we can write the formula as rho 1 GH1 is equal to rho 2 GH2. Now here we have to calculate the height. That is the height of the wine column. H2 is equal to question mark. Now by using this here we can write H2 is equal to rho 1 GH1 by rho 2 into G. Now here G get cancel the terms. Therefore the value of H2, the formula for H2 is equal to rho 1 H1 by rho 2. Put the values of density 1 and density 2 and the height H1. 13.6 into H1 0.76 divided by density rho 2 984. the calculation part of H2, we are getting the answer as 10.5 meter. Therefore, the value of the H2, the height of the wine column H2 is equal to 10.5 meter. From this we can tell that the height of the French wine column from the normal atmospheric pressure is 10.5 meter. From the normal atmospheric pressure it is 10.5 meter. Next question. A raindrop of a radius 0.3 millimeter falls to the air with a terminal velocity of 1 meter per second. The viscosity of the air is 18 into 10 raised to minus 5 points. Find the viscous force on the raindrop. We have to find here viscous on the raindrop. Now let us consider the given term. They have given that the radius of R is equal to 0.3 millimeter, or this can be also written in the form of meter. 0.3 into 10 raised to minus 3 meter. Next, they have given that the terminal velocity means V is equal to 1 meter per second. V is equal to 1 meter per second. Next, the viscosity of the air is 18 into 10 raised to minus 5 point. Neta is equal to 18 into 10 raised to minus 5 point. Or this can be also written as 18 into 10 raised to minus 6 Pascal second. Next, here we have to find the viscous force on the raindrop. F is equal to question mark. The formula F is equal to 6 pi neta RV. The formula for the viscous force, we are considering F is equal to 6 pi and 6 pi neta RV. Put the value of all this. F is equal to 6 pi means 3.142. The value of neta is 18 into 10 raised to minus 6. The value of R is 0.3 into 10 raised to minus 3. Next, V is 1. Now, the calculation part of F, we are getting the answer as 1.018 into 10 raised to minus 7. The SI unit of the force we are considering as the Newton, and therefore the value of the viscous force on the raindrop is F is equal to 1.018 into 10 raised to minus 7 Newton. Now next question. Calculate the height of the water which will rain in the capillary tube of 1.5 millimeter, and that is your diameter. The surface tension of the water is 7.4 into 10 raised to minus 3 Newton per meter. Here we have to calculate the height of the water. H is equal to question mark. Now next, they have given that diameter of a capillary tube D is equal to 1.5 millimeter. Convert this answer into meter. 1.5